And so I will post the video of the class. Someplace where you can all get it if for some reason you really wanted to watch a video of it or whatever, but it shouldn't be some huge deal. So, before we get started with anything else, I'd love to know about spreadsheets. Andrew turned his in like 4 minutes after class, I think, on the last time we met. I don't know if it was that fast, but it was right away. Man, that guy did it right away. So Andrew must be comfortable with spreadsheets. Did you feel like you got the answers right? Did you think you got them all working?
Yeah, for the most part. The first one I couldn't like plug it into a calculator for some reason, but I still got the correct answer.
You got the correct answer?
Yeah.
Okay.
The function or whatever.
Cool. Cool. Malia, I saw that I got yours over the weekend. How'd it go?
You got it. Didn't you get it like last night at like 11:30? Yeah.
Yeah, something like that.
It went good. I got it done fast, but I just kept on checking it
Okay.
until.
Do you spell your name John like J-O-N?
Yes.
Okay.
Yep. Okay. This was new for Haley. And she had some interesting questions.
I actually don't think I got it.
Be it helping?
I was entering the wrong thing.
Okay. You told me you're having problems with the numerator of the M term or something like that, right?
Yeah.
And so, real quick, if we take a look on the equation for M, which is on page 27 or something like that, and I'm just going to look at that numerator real quick, because I bet if you had a question about that, other people either had questions and didn't want to ask or something like that. And so let me just look real quick. In that numerator, there was an n, there was a sum of the xy's, there was a sum of the x's, and there was a sum of the y's. Now, I'm curious, which of those terms which part of this was the hard one? Or what were you having trouble getting into?
I was entering the wrong row.
Oh, okay.
So that's why it wasn't working.
Okay, but you made yourself a column that had the x, like, so you already had a column with a whole bunch of x data and a bunch of y data, right? And you made yourself a new column of x, y's, right? That was just this one times this one, and copied it down. And then you use that equals sum function across this to get that sum of x, y's and all that kind of stuff, right?
I got all that. I just wasn't entering it. I was entering the wrong letter.
Oh, okay.
So then the value wasn't coming up.
Okay, but you did get it to work then?
Yeah.
Okay, fantastic. Well, as I was saying the other day in class, we're not going to, I mean, this, don't get me wrong, there's other things we're going to be doing that involve statistics in the class. We'll probably actually use even equals sum and so on again. It might even happen just because of what problem sets we choose is that equals slope and equals intercept and so on. We may in fact even do those again. But realistically, the real skill we're learning here is all about how we're going to be using spreadsheets to solve problems. You know, adding a column that contains some intermediate values. Making ourselves a little table of like, you know, notice how we made like ourselves a little table that had like sum of x, sum of y, sum of xy. And then we could just use those values in other equations. That's a good problem-solving strategy when you're using spreadsheets. Okay? So it's really more the strategy and starting to get a sense of what worked and stuff like that. Because especially when we start getting into like matrix tableaus and simplex tableaus and things like that are these problem-solving strategies later, the book tells you to do them on paper, but it's way too much arithmetic. You'll just make a mistake and then you can't find the figure out what the right answer is. And like I said, there are literally thousands of functions like equal sum and so on built into Excel and Google Drive, Google Sheets and so on. Like for example, I mentioned that column that was x, y. There in fact is already a built-in function called sum product that we could have done where you just point to the x's and you point to the y's and it understands multiply this one by this one and then add them up. I mean, there's a zillion of these kinds of things built in. It's just that we'll never see sum product again. That didn't seem like a very useful way. It's something I use a lot because, like, for example, when I'm figuring out grades, I have the weights of each problem and how many points you got in each problem, and then you multiply the weight of that problem times the number of points, and then you add up, you know, the weighted value of each problem. It's something a teacher uses a zillion times, but it's not something we're going to be doing. All right? Do you feel like that was something today that you needed more time on? did everybody here turn in or will soon turn in, you know, like by the end of class, this assignment? Like, did you get it done?
Yeah, no, I got it done. I just turned it in.
Oh, okay.
I was thinking about time and stuff. I was thinking, like, if we had a little bit more time in class.
To talk about this one?
Yeah.
Okay, I'm trying to, like, here's what I want to do. I want to move forward so that we, you know, the video isn't like an hour and 10 minutes long or whatever. Can we,
No,
we'll cover the new material and then turn the camera off and we'll start working on that. Does that
Oh,
make sense?
no, I'm fine now.
Okay.
I'm fine now. It was just when I was working on it.
Oh, okay.
Yeah.
Okay, I just want to make sure we're moving forward and so on. All right, then, we're going to move forward into chapter 2. Now, the good news about the beginning of chapter 2 is it's stuff you've done before. You absolutely, definitely did this in pre-calc. You probably did this in, like, Algebra 2. But it's just a matter of, oh boy, that was a long time ago, and so on. Plus, as you know about this book, it's going to be a little harder and a little more applied. I mean, that's the nature of this class, is that it's more about applied problems, learning how to solve such things. And what chapter 2 is basically about is about solving systems of equations. Now, when we say systems of equations, that should, like, trigger a stress response from you from back in pre-calc. Or something you're like, oh, that was easy. But back then, you had systems of equations like 2x plus 3y equals 7 and x minus y equals 10. And you had a chapter about this in pre-calc where we learned a ton of ways to solve something like this. Mullian, name some of the ways that we learned how to do this. Do you remember?
Like substitution.
Substitution,
Elimination.
elimination,
Other things that are relevant.
Gauss-Jordan, echelon method, reduced row echelon form, Kramer's rule. Are you developing a stress response yet?
Yeah.
Yeah, absolutely, right? There was a whole echelon. Well, guess what today's section is called? Solution by the echelon
I
method.
really don't remember.
That's okay, but you remember that such problems existed. That's where we're starting first, right? Because these are two equations. It could be more. In general, there should be the same number of equations that you have variables. In pre-calc, we got kind of fancy. We even had some that were 4 equations and 4 variables. Although usually in pre-calc, we did either 2 or 3 equations, or 2 or 3 variables. Each of them is and that's hence the words a system of equations. Okay? And you did this kind of thing to death in pre-calc. And most of the time in pre-calc, this is what it looked like. It was just x's and y's and maybe z's, right? Most of the time, it's just not the nature of that pre-calc book. Not that many of the problems they give you are a story problem. Okay, that just isn't what that book is like. This book is more about story problems or actual applications, okay? Which often means we have to figure out how to set up this thing. Instead of it just being, it gave us some problems, now we need to come up with it. But we'll get there. Real quick though, we do need to make sure we understand what this is. If we took this equation right here, we could rearrange this and make something that was like in the slope-intercept form that everybody loves, right? With a little work, you can see how you can change this to 3y equals negative 2x plus 7, which is with a little work, you could change it to y equals negative 2/3 x plus 7/3, right? With a little rearranging, a little bit of algebra 1, you can see how this becomes just a line. I could make a graph of said line where it has a y-intercept of 7/3, which is something like right there, and has a slope of negative 2/3, which is something like this. That is the graph of that top equation. And you can see with a little bit of Algebra 1, we could pull this over to this side, and we could then, with a little more Algebra 1, make it like this, right? And I'll use a different color, and I just made these equations up, so they're horrible. But I made it look something like this. That's terrible with this marker not being very good. So what is the solution to this set of equations? MJ, do you know what we mean when we say like the solution to these equations then? What is the solution to this? Is the graph the solution? Is this line the solution? What do we mean?
That's where those points intersect.
It's the intersection of the 2 points, right? This spot right here, which if this were plotted more carefully, would be some set of numbers. Let me just say 9, 1, which is not going to probably be right. Heck, let's do a better guess. How about 11, 1? Let's just say that was the right answer. That's where that point is. That is the only place on that graph that solves both of those equations. That makes both of those equations true. Right? Everywhere on this blue curve, this spot right here, which is 0, 7/3, makes the top one true, but doesn't make the bottom one true. This spot right here, which is 0, -10, makes this equation true, but doesn't make this one true. This place right here, which we're pretending is 11, 1, but presumably isn't quite that, is the only place that makes them both true. So if these equations weren't just blah, 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 x, blah, 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 y, but was something meaningful, and we had to make both of those equations that were meaningful true, that's the only place that would work. That's what we're doing with the problems. Now, as is always the case when you're learning about solving equations, they have to be pedantic jerks about it. Do you know what the word pedantic means? Pedantic means teacherly. And not in a happy sense of the word, like bring your teacher it out because he's the best teacher you've ever had. I blush. No, teacherly in the pain in the butt kind of way. You know what I'm saying? We're like, there's too damn many details that don't really matter. We have, in a very pedantic sort of way, a pedant was a kind of cruel teacher. Hence the word pedantic. They want to point out that it only really works if these lines cross. And they wouldn't have had to, right? The two equations, for example, might have made lines that were parallel. Then there is no solution. And they might have made lines that were right on top of each other, in which case you get to infinite numbers of solutions. Any place on the line would work. By and large, in the real world, that doesn't happen. By and large, there is a correct answer. If this were this is, X is the number of cookies to bake at the bakery, and Y is the number of pies, and you have this many minutes to make a cookie, and this many minutes to make a pie, and you have this many total minutes, and this is how much it costs to make a cookie, and this is how much it costs to make a pie, and this is how much money you have, there's a correct answer. There is one answer as to what's the best number of cookies and pies to make. In general, the answer is not. There's an infinite number of choices of cookies and pies you can make, because odds are it's not the case that a negative number of cookies, for example, is the right answer. Or an infinite number of cookies is the answer. In the same way, it's not in general the case that there is no answer. The correct answer is don't make anything. Okay. By and large, in real world problems, these kind of things don't happen. Whereas in pre-calculus, they happen all over the place, right? We were pedantic about that in pre-calculus. Now, again, before we get too far in figuring out how to set up problems with these, we're going to review how we actually solve ones like this that are just mathy. Just X's and Y's. Now, when we called out names, by the way, did you notice how I'm consciously working on not talking as fast as I usually do? I feel like I'm not going. Like
I didn't feel that.
You didn't feel like I was talking slower than I usually do?
No, I didn't feel like you ever talked fast.
Are you kidding me?
I'm
Oh my
just
gosh.
listening to stuff at like rapid fire speed.
I chatter like a squirrel.
It's worse if you listen to a podcast in Japanese at
Oh my
times 1.5 speed.
There you go. All right. When we were calling out examples of methods that we learned in like chapter 6 of the pre-calc book, back in like November of last year, people threw out like elimination, substitution, Gauss-Jordan, blah, blah, blah. And the truth is, for systems of two equations with two unknowns, two equations, two variables, actually, those kind of turn out to be all the same thing, right? It wasn't until you got to some of the more obscure methods like Cramer's rule and stuff that there was real differences between the different techniques. You know, the ones that involve like matrices and stuff like that, right? Actually, all of these methods were kind of the same thing when you were just talking about simple little systems of two equations and two unknowns. In the real world, most of the time there's more than two variables. There's not just cookies and pies, there's cakes and eclairs and cupcakes and well, you know, there's a whole list of things, right? So actually it turns out though that when there's just two equations and two unknowns, they're not all that different. And this business of what they're calling echelon is basically the same thing as like substitution. Actually, if I were to call out a name of a method that you learned back in pre-calc that should not scare you anymore, how about elimination? Where we come up with a new way to eliminate, oh wait a minute. We got to remember how you do that. You know, we can do things here, right? We can make changes to one equation or the other, like there are rules. We can do things like multiply one of these equations by a number. We can do things like add this equation to this equation or subtract this one from this one. Whatever it takes. And what's the plan? I mean, I can do whatever the hell I want, right? Like, I'm going to go ahead and do it on another line, but I can take this equation and multiply it by, I don't know, 7, let's say. 7x minus 7y equals 70 is the same thing as this one is. We haven't hurt anything. Any number of x and y that works here will work here too. Just multiplying the whole thing by 7 doesn't change the answer. So, what was the plan though? What was the plan when we were doing things like adding one equation to the other? Or multiplying one of the equations by a number? What was the plan?
To cancel out variables.
To get something to go away, right? So, like Andrew, if you were looking at this one right here, what do you want to make go away?
Probably the y.
You like the y. Okay, how are you going to make the y go away?
Just multiply by 3.
If I multiply this equation by 3, this equation can become 3x minus 3y equals 30. And how did that help, Andrew?
You get rid of the y, so now you're
How are you going to... What do you mean by get rid of the y?
You have to add the two together.
Yeah, now it's perfectly fair to replace this with this one plus this one. Right? So this one plus this one is now 5x plus 0y equals 37. Did I do the math right there? I think I did. Right? This one plus this one, this one plus this one, and this one plus this one. Yeah. Okay. Well, wait a minute. 5x equals 37 is pretty easy to solve. It's not a happy number, right? But x equals 37 fifths. I just pulled these numbers out of nowhere, right? So I mean, I didn't choose a nice one that gives integers and things like that. Okay, so whatever the solution to this set of equations is, that's part of it. How are we going to now know what the answer is for y? If that's x, how are we going to know what the answer is for y? We're going to do what? We're going to put this bad boy here into one of these equations up here. Well, actually, any of them along the way, as long as we haven't made any arithmetic errors, any of them would be fine. Which one do you think is probably your best bet?
X minus y.
Yeah, I think this is the one that makes me happiest, right? This one looks like the least math to make it happen. But either one would work. And you can put that one into here and get 37 fifths minus y equals 10, and you'll get a number. I don't feel like doing it. It's awful, right? Because I just guessed these numbers. But they would work. And you would have the solution. That's what they're calling echelon method. Okay? You might remember that word echelon from pre-calculus, and we kept promising that any day now Dr. Strachey was going to go and actually look up what the word echelon even meant, and it never did. Because it just, whatever. But I mean, if we called this elimination, we would not be... What we're really doing is getting into the form where we had something like 2x plus 3y equals 7, and then we had it with one fewer variables in this row. So we got it into a form like 5x equals 37. So there was one fewer variable. And if we had 6 equations and 6 unknowns, this becomes a thing, right? Where like the first equation has 6 variables, the next one has 5, the next one has 4, or whatever. But we never did one as complicated as 6 variables. In fact, I think we only did some that had 3. Right? It just gets to be a mess. And you might remember, because pre-calculus has to be a pain in the butt, that there were some where it was like to try to make it like a triangle. Like instead of going for the 5x here, they had gone where they try to make it look like a triangle. So like they get rid of the x here, so maybe this works out to 5y equals 28. So you kind of get a triangle shape. And in fact, if we had like 6 equations, the first one would have 5, then 6, and then 5, and then 4, and then 3, and then 2, and then 1. I think, was that reduced echelon form or something like that, or I forget. There was row echelon form, and like reduced echelon form. And someday, very soon, because I'm teaching pre-calculus, I got to remember all that. Today is not the day. Today, basically, this is what we're doing. Honestly, once you've done one or two of them, it's no big deal, and we'll do a couple real quick at the, no, let's do it now. But let's not be lonely. Andrew, why don't you scooch over there with Malia? And let's all have a happy memory from pre-calc by doing problem number 1 on page 52 in 2 little groups. Show me how you're going to do problem 1 on page 52. X plus y equals 5. What's going on?
We could just use elimination or like substitution, right?
Yeah, I mean, what it's calling echelon, when you're only talking 2 variables and 2 unknowns, I'm not even sure there really is a difference between that and like elimination. Okay? Hey, what was the word? Do you happen to remember what the right word was for when you took? Okay, now we know the x, and we're going to plug it back in. Do you happen to remember what the technical term for that was? Back substitution. Yeah.
I haven't taken all of that stuff yet, so.
Oh, you haven't taken pre-calc? No, because you're in
No,
pre-calc.
I'm taking it now.
I'm sorry.
Oh yeah, I looked up what echelon means, and it means a level or rank in an organization, profession, or society.
Well, okay.
From French.
Yes, yes. Okay, yes, because you could be like in the upper echelons of your corporation or something.
Right.
But how does that apply here? Like,
Well, it looks like you arrange the stuff.
to have
in
like kind of a
levels.
hierarchy?
Yeah,
Yeah.
it makes sense. I
Okay.
just didn't solve the thing.
Echelon. Okay. All right, so we're going to need a good plan here as to how to solve this problem.
Well, a couple words you're saying are familiar, but they're just not.
Yeah. Were you able to solve this problem?
Yeah. Well, I understand like the simple things. I don't remember like Kramer.
I know. Well, Kramer's rule is one of the hard ones. I don't remember
Is
it.
that the one where like you make it like with the 1 and zeros, and then you have to like?
No, Kramer's rule is one where it has determinants of matrices. Like we would make a matrix. 1, 1, 2, 2 is one of the matrices. 1, 1, 2, negative 2. And then to solve for the x, it's going to be what? You put these numbers in over here, 5, 2, 1, negative 2.
Wasn't there one? Which one was the one where like on the other side you did like you had to end up with it in a matrix, but like with ones and zeros and like the line.
I think that is reduced row echelon.
Oh.
Yeah.
I think the scariest thing was like,
Good morning.
Morning.
Sorry to interrupt your video, Sierra.
Yes.
This is Mr. Shraggy. Hi. This is Miss Holly Moore. She's going to be sitting next to you.
Excellent.
She got the blue memo too.
Excellent.
On it.
Excellent.
This
Yes.
is finite, right? No, what is this?
This is finite.
Finite. Okay.
This is like half of finite.
Yeah, where's the other guy?
I didn't hear from Luke, and I had a message from Lisa that wasn't entirely clear, but I believe she is out.
Yes.
Yeah,
Okay. She's with Maddie.
she is with Maddie. Yes.
Alrighty. See you guys.
Yep. Bye. Good to see you, Holly.
You too. 4 and then it goes 3.
All right. So what do people want to do with this one? First off, am I freaking you out about this material? Like, can you solve things like that? I think they do some of this like algebra 2 and stuff like that.
Well, it freaked me out at first when you was talking about echelon method, and I'm sitting there and I'm like, wait a minute, I have no idea how we solve this. And it's like, it's just substitution.
Yes.
Oh,
Right.
okay, I can do that.
Right.
So
Back in
that's-
pre-calculus, or in the future, there's a future past tense.
Yeah.
There exists a time in the future where this will have been in the past for you.
Right, right. No, I get
All right.
that.
Fantastic. English is such an efficient language that we don't have a future past tense, right?
Yeah, well, it's just annoying that we technically don't even have a future tense.
Anyway, all right. So what did you guys do to solve this problem?
Multiply the top part by 2.
Yeah, I would agree. I think multiplying the top part by 2 is a good plan.
Started eliminating crap.
And then you added 2 of them together to get like rid of the y.
Yes.
So you had like something like 4x equals 12, right?
Yes.
And I bet you weren't terribly amazed to discover using your algebra skills that was a 3. Then to use the correct vocabulary word, we're going to use back substitution. We plug that x back into one or the other of these guys. It doesn't particularly matter. Let's just say this one, which makes 6 minus 2y equals 2. You pulled that one over here. Let's see, 2 minus 6 is negative 4. That probably makes y equal to 2, right?
Yep.
So if we actually plotted these guys, the intersection of the 2 lines was 3, 2. Yeah, Andrew.
Yeah, I don't know what I did actually. I mean, I did it differently, so I just messed up somewhere.
Or did
Divided by 2 on the second one.
you divided by 2 on the second one and got 1? Okay, so then you added this one and this one. No, what did you add? What did you do with this new equation then?
Okay.
Then you did that so that you could add it to this one and this one. So you got,
Actually, I did that and I plugged this in for x here. I don't know if I was supposed to do that.
oh, okay, that was another one of the methods. You're right. But yeah, I would think that if you had taken,
If I
I'm not sure, so something must have gone wrong. You know what I'm saying? I mean, yeah. So yeah, did you see what you did?
Yeah.
Okay, fantastic.
What?
Honestly, I don't think the arithmetic here is going to be the problem. I'm pretty confident that you guys are going to be able to do the arithmetic here and get these things to work. The setting them up is the harder part. Let's dwell on that for a minute. Because again, yes, if you look at page 52, it has some that look like pre-calc. I mean, they're just numbers and letters and stuff like that. But that's not so exciting. In contrast, let's just go to the page 45, the beginning of the chapter. It can be harder to see how to do this when it's a story problem. For example, on page 45, it says, suppose that the animal feed is made from 2 ingredients, corn and soybeans. 1 serving of each ingredient provides a certain number of grams of protein and a certain number of grams of fiber, as shown below. So, like for example, corn has 3 grams of protein per serving, and soybeans has 10 grams of protein per serving, and so on. All right. Suppose we need to know how many servings of corn and soybeans should be used to make feed that has 115 grams of protein and 95 grams of fiber. Now, later in the course, this is going to get way more complicated. But right now, we get to have happy, simpler things. what are we doing here? We're saying that whatever the critter is or whatever, they've got to have 115 grams of protein. Here, I'm going to make an equation that I'll just call protein. Did I spell it wrong? No, that's right, actually. They need 115 grams of it. And they need a certain number of grams of fiber. I'll call that equation fiber there. And it's 95 grams of fiber. Okay. You're going to have X is the number of servings of corn. I don't think servings is a very good use of words here. Let's use that scoops or something like that. In fact, why don't we just so it's not confusing, how about scoops? Can you picture this here? You're trying to feed the horse. Okay? Horses don't eat soybeans as far as I know, but whatever. Okay? They're going to have a certain number of scoops of corn and a certain number of scoops of soybeans, and you want it to add up to 115 grams of protein. And you're going to have a certain number of scoops of soybeans. Now, a scoop of corn gives you 3 grams. So however many scoops you gave them, 3 times that is how many grams of protein they got. Plus, how many, is it 10? I can't remember. 10 grams per scoop of soybeans. So whatever X and Y are, 3X, so 3 times the number of scoops of corn plus 10 times the number of scoops of soybeans has to add up to 115 grams. And in the same sort of way, the which one is it? Fiber? Corn has a lot of fiber. 11 times the number of scoops of corn you used, plus 4 times the number of scoops of soybeans, better add up to 95. Once you've got it into this form, it's just row echelon, substitution, whatever you want to call it. For that matter, once you have other method here, if you look ahead here, on solution of section 2.2, using Gauss-Jordan 2.3. 2.3, adding and subtracting matrices. Oh well, we got there. Everywhere else we do this using graphs and stuff later and so on. Once you got it to this, it's not really the end of the world. It is, though, a little insight into what this book looks like.